Comparison and interpretation of mode and mean. Welcome, everyone. Today, we are going to dive into a very important topic in statistics, the comparison and interpretation of the mean and the mode. To start off, it is important to understand that in the study of statistics, both the mean and the mode fall under a specific category called measures of central tendency. Now, that might sound like a complex term, but all it really means is that we are looking for a single value that can best represent the middle or the center of our entire data set. However, even though both the mean and the mode share this same goal, to find a representative value, they do not arrive at that center in the same way. They use entirely different mathematical logic to get there. As we move through this lesson, you will see that simply knowing how to calculate them isn't enough. The real skill lies in understanding when to use one over the other. Choosing the wrong measure can lead to a misleading conclusion, so mastering this distinction is absolutely crucial for performing accurate and meaningful data analysis. Let's move on to the next slide to look at the specific definitions of each. Conceptual definitions. First, let's look at the mean, which you likely know as the arithmetic average. To find the mean, you simply add up every single observation in your data set and then divide that total sum by the total number of observations you have. Now, if you are working with group data, where data is organized into intervals, the process is slightly more advanced. In that case, the mean is calculated as the weighted average of the class marks. To really understand the mean, I want you to think about its mathematical essence. It represents the balance point of your data. Imagine a seesaw. The mean is the exact spot where the data would balance perfectly. Because of this, the mean is highly sensitive. This means it is affected by every single value in the set. If even one number changes, the entire mean will shift. Next, let's turn our attention to the mode. Unlike the mean, the mode is simply the value that appears most frequently in your data set. If you are dealing with group data, we look for the modal class. That is, the interval with the highest frequency, and identify the value within it. The mathematical essence of the mode is different. It represents the most popular or most common value. Because it only cares about frequency, the mode has a very different kind of sensitivity. It is not affected by extreme values or outliers, as long as those extreme values don't happen so often that they become the most frequent observation. Now that we've established that both the mean and the mode are tools used to find the center of our data, let's dive deeper into their conceptual definitions so you can see exactly how they differ. Keep these definitions in mind, because in the next slide, we are going to see exactly how this difference in sensitivity causes the mean and mode to react differently when we encounter extreme outliers. Key differences in interpretation. The real difference between the mean and the mode becomes most evident when we observe how they react to the specific distribution of a data set. First, let's look at point A, the impact of extreme values, which we often call outliers. Imagine a data set where most numbers are small, but you suddenly add one or two values that are significantly higher or lower than everything else. Because the mean is the mathematical average, the balance point we discussed earlier, it is highly sensitive. This means the mean will be pulled toward those extreme values, potentially giving you a result that doesn't represent the majority of the group. However, the mode is much more stable. Since the mode only cares about what occurs most frequently, those rare extreme values won't change the mode at all, provided they don't become the most common value. Next, let's examine point B, the symmetry of data. This is a crucial concept for understanding the shape of your data. In a perfectly symmetric distribution, think of the classic bell curve you might have seen in biology or physics. The mean and the mode are actually equal. They sit right at the same center point. But as we will see in our upcoming shoe store example, data is often asymmetric or skewed. In a skewed distribution, the mean and the mode will differ. The mean will shift away from the center, moving toward the long tail of the distribution, while the mode remains anchored at the peak, representing the most frequent value. Now that we have established the fundamental definitions of the mean and the mode in the previous slide, let's move on to slide 3, where we explore how these two measures actually behave when the data starts to change. Keep these behaviors in mind, because in the next slide, we are going to apply this exact logic to a real-world scenario involving shoe sizes to see this pulling effect in action. Real-world example, shoe store inventory. Now that we have discussed the theoretical definitions and how outliers affect our calculations, let's put this into a practical context to see these concepts in action. Imagine a shopkeeper who sells shoes. To manage his business, he records the sizes of the last 10 pairs of shoes sold. Our data set for these sizes is 7, 8, 8, 8, 8, 9, 10, 10, 11, and 15. Let's walk through the analysis in 3 steps. Step 1, let's calculate the mode. If we look closely at our list, we can see that the size 8 appears 4 times. Every other size, like 7, 9, or 10, appears much less frequently. Therefore, the mode is 8. In terms of real-world interpretation, this tells the shopkeeper that the most common shoe size requested by his customers is size 8. Step 2, now let's calculate the mean. To do this, we first find the sum of all the sizes. When we add 7, 8, 8, 8, 8, 9, 10, 10, 11, and 15, we get a total of 94. Since there are 10 total observations in our dataset, we divide 94 by 10, which gives us a mean of 9.4. So the mathematical average size is 9.4. Step 3, this is the most important part, the comparison and analysis. Notice that here, the mode of 8 is less than the mean of 9.4. Why did this happen? It happened because of that outlier we mentioned in the previous slide, the size 15. That one person with very large feet pulled the average upward, making the mean higher than the most common size. So, how does the shopkeeper use this information for decision-making? If he wants to know which specific size to stock most heavily in his warehouse to satisfy the majority of customers, the mode is his most useful tool. However, if he needs to calculate the total amount of leather required to manufacture all these shoes, the mean is much more useful for his overall calculations. As we will see in our summary table in the next slide, choosing the right measure depends entirely on the question you are trying to answer. Summary table for quick reference. Now that we have explored the conceptual differences and seen that real-world example with the shoe store, let's bring everything together. I've prepared this summary table for you to use as a quick reference guide when you're studying. Let's look at the first row, the definition. As we discussed earlier, the mean is simply your mathematical average, whereas the mode is the value that appears most frequently in your data set. Moving down to the calculation row, this is where the math gets a bit more technical, especially for grouped data. For the mean, we calculate the sum of the frequency times the class marks, all divided by the sum of the frequencies. For the mode in grouped data, we use a more complex formula. The lower limit of the modal class, plus the quantity of frequency 1 minus frequency 0, divided by the quantity of 2 times frequency 1 minus frequency 0 minus frequency 2, all multiplied by the class width, or h. Next, let's look at sensitivity, which was a key point in our discussion on outliers. The mean is sensitive. It is affected by every single value in your data, including those extreme outliers that can pull the average away from the center. However, the mode is much more robust. It is not affected by outliers as long as they don't become the most frequent value. In terms of the best use case, you should use the mean when your data is distributed evenly or symmetrically. But if you are trying to identify the most common category or the most popular item, like the shoe size in our previous example, the mode is your best tool. Finally, let's look at how we represent these visually. Think of the mean as the center of gravity of your data set, the point where everything balances out. The mode, on the other hand, represents the peak of the frequency or the highest point on your distribution curve. Keep this table in mind, because in the next slide, we will wrap up with the most important key takeaways from today's lesson. Key takeaways. First, remember that while the mean provides a great general average for your data, you must be cautious. As we saw with the size 15 shoe in our previous example, The mean can be quite misleading if your data set contains extreme outliers, because those outliers pull the average away from the center. Second, keep in mind the unique strength of the mode. The mode identifies the most common occurrence in a set. It is also incredibly versatile because it is the only measure of central tendency we can use for non-numerical or categorical data. For instance, if you were finding the most popular color of shirt sold, you couldn't calculate a mean color, but you certainly could find the mode. Third, pay close attention to the relationship between these two values. Depending on how your data is distributed, the mode can be less than, equal to, or even greater than the mean. It all depends on the shape of your data. Finally, a very important rule for your exams. The mean is equal to the mode only in perfectly symmetrical distributions, such as a standard bell curve. In any other skewed distribution, these two values will diverge. Now that we have looked at our summary table and worked through our shoe store example, let's wrap everything up with some key takeaways to ensure you have a solid grasp of these concepts. In our next slide, we will look at some common pitfalls to avoid so you don't make these mistakes in your own calculations. Common mistakes. Now, as we wrap up our lesson, I want to highlight some common pitfalls that students often encounter when working with these measures. Being aware of these mistakes will help you avoid errors in your exams and, more importantly, in your real-world data analysis. First, let's talk about terminology. You might often hear people use the word average to describe the mode, but in a mathematics classroom, we must be much more precise. When we say average, we are typically referring to the mean, that mathematical balance point we discussed earlier. To avoid confusion, I want you to practice using the term most frequent whenever you are describing the mode. Precision in language leads to precision in thought. Second, be careful not to develop an over-reliance on the mean. It is very tempting to assume that the mean is always the best way to represent a group of numbers. However, as we saw in our shoe store example with the size 15 outlier, the mean can be pulled away from the center by extreme values. Always ask yourself, does this mean actually represent a typical member of this group, or is it being distorted by an outlier? Finally, never ignore the context of the problem you are solving. Mathematics isn't just about calculating numbers, it's about making decisions. For instance, if you were tasked with ordering uniforms for a class, calculating the mean height would be a mistake. A mean height of, say, 5 feet 6 inches doesn't help you if most students are actually either 5 feet tall or 6 feet tall. In that scenario, you need the mode, the most common height, to ensure the uniforms actually fit the majority. Always look at the purpose of your data before you decide which measure to use.